Lesson 6.6, scale drawings and models. We're going to be working with proportions in this lesson. The lengths and widths of objects on a scale drawing or model are proportional to the lengths and the widths of the actual object. You guys all know what a blueprint looks like, or a scale model if you've ever built a model car or airplane or something. Then you know that on a blueprint, the size on the blueprint, it's just a big piece of paper, and the doorway on the blueprint might measure an inch wide, but the doorway itself is not going to be an inch because, then people wouldn't fit through it. So you've got to have that inch on the paper represent some actual measurement in real life. And we're going to talk about how to interpret those kind of things in this lesson. So let's start with scale. The scale is the ratio of the length on the drawing compared to the length on the actual object. So we're going to be working with ratios. And the example here that we have, a 2-inch drawing of a window represents an actual window that is 8 feet tall. So you've got a blueprint, a picture of the house that's being built. And on the drawing, the window is 2 inches tall. But in real life, the window, when the architect or the carpenter builds it, in real life it's going to be 8 feet tall. The question is then, what is the scale of the drawing? We'll always start out with the information that you know, and always put the paper dimension or the model dimension on top and put the actual dimension on bottom. So 2 inches over 8 feet, we're going to write those as a comparison. But what we want is not to have 2 inches on top. We want to know what the scale is, and the scale is always written with a 1 on top. So we want 1 inch on top. And this is a pretty easy example to see what we need to do, but some of them will be a little more difficult. You can always set it up as a proportion and then use the fish method to solve for x. In this case, 1 times 8 is 8. 8 divided by 2 is 4. So the scale would be 1 inch over 4 feet. So every inch on the drawing represents 4 feet in real life.
Couldn't you just do, since you put that as a 1, couldn't you just take 8 divided by 2?
You can, and some of them will be easier. Some of them will be that simple, but others of them are going to have like decimals and kind of weird numbers in them. So it will always work to set it up as a proportion and use the fish method. So that's just the way I'll show it on all the examples that we do. So this is the answer. The scale of the drawing, 1 inch over 4 feet. That's all you have to do. Okay? The other thing that we're going to be working with is scale factor. If the scale drawing and the model have the same unit of measure, the scale can be written without units. This is called the scale factor. So on the previous example, we had 1 inch over 4 feet. That's a scale because they have different units of measurement. But we want to talk about a scale factor where they have the same unit of measurement. So suppose the scale model has a scale of 1 inch equals 2 feet. Anytime in any of the problems that you have today, if they give you the scale, before you even read anything else, just go ahead and set that up as a ratio because you're going to use it. 1 inch over 2 feet. That's going to be your starting point. Now I want to get this scale into a ratio where there are no units of measurement. We did this earlier. We talked about units of measure in Unit 3 when we were doing conversions. So what do I want to do here to convert this into a factor where there are no units of measurement?
Do like 1 foot on top and then put 12 inches on bottom?
Exactly. 1 foot on top, 12 inches on bottom. And look what happens to the units of measure. This unit of measure cancels out. This unit of measure cancels out. Now all I have left is numbers, and that's what I want for a scale factor. You don't want any units of measure involved, you just want numbers. Multiply straight across, 1 times 1 is 1, and 2 times 12 is 24. So the scale factor is 1 to 24. And the good thing about using a scale factor, the interesting thing about it is, whereas before we were talking about feet and inches, and that's kind of what you would have had to measure in if you're going to use the scale, scale factor works with any measurement. And what if I'm measuring in centimeters and I measure something 1 centimeter long? Well, how many centimeters is it in real life? 24.
Yeah.
What if I measure in yards? It's 1 yard long. How long is it in real life?
44.
It's 24 yards in real life. What if the scale was 1 mile? How long would it be in real life?
24.
24 miles. So this works with any unit of measurement, And I don't have to worry about making any conversions at that point. So the scale factor, you're gonna multiply by a conversion factor to get rid of the units of measurement so that you can just use that number. All right, I'm gonna work through about three examples with you, and then we'll get to the homework and I'll get started on the homework with you. First sample problem. A blueprint drawing of a skateboard ramp is 11.4 inches long. If the scale of the blueprint is 1 inch equals 6 feet, what do you do as soon as you see the scale?
Put it in.
Just write it down. I don't know what they're asking yet, but I know I'm gonna need it. 1 inch to 6 feet, that's the scale. What is the length of the actual ramp? If we're using scale, then you're gonna wanna set up a proportion. And to set up a proportion, I need an equal sign.
Put 11.4 on top,
Why does 11.4 go on top?
because it's inches.
Okay. Because it's inches, and since I have inches on top here, I want inches on top here since I have a proportion. Also, you always want to put the paper dimension or the model dimension on top, okay? Then what is the length of the actual ramp? On paper, 1 inch equals 6 feet. In real life, so on paper, 11.4 inches on paper represents what length in real life is the question. 11.4 times 6 divided by 1.
68.4.
68.4 feet. Don't forget to label your answers. Labels are key for your answers
Do we need to
on a
put
lot of these.
X equals?
Hmm?
Do we need to put X equals or is it just
Oh, you can. X equals 68.4 feet. Okay, next I want to determine the scale factor. So again, I want to start with the scale. You're always going to start with that. 1 inch over 6 feet. And what's the key thing about the scale factor? What do I want to do?
We gotta put you wanna change 24 inches on the bottom. Measurements cancel out.
Okay, measurements cancel out. So I want to set up some conversion factor so that measurements cancel. So how do I cancel feet?
1 foot.
Put 1 foot on top. How do I cancel inches?
24 inches on bottom. I mean 12.
12 inches on bottom, okay? And now this unit cancels, and I have 1 over 72. So the scale factor is 1 to 72. Now I can measure in any unit I want, centimeters, meters, whatever. And I can figure out how big it will be in real life. Okay, next example. An architect is drawing plans for a courtyard that will measure 45 feet long and 30 feet wide. So it's going to measure 45 feet long. 45 feet is what I meant, right? By 30 feet wide. And that's the actual dimensions in real life. Using a scale of 1/2 inch equals 10 feet, what do you do as soon as you see the scale? Go ahead and write it down. I'm going to write 1/2 as a decimal because it's easier to work with. 0.5 inches to 10 feet. How big will the courtyard appear on the drawing? So in real life, it's 45 feet by 30 feet. And you've got to do this in 2 steps. You can't interpret or make proportions that do both of these dimensions at one time. So I need to set up one proportion to change 45 feet into my paper drawing measurement. And I need to do another one to change 30 feet into my paper drawing measurement. So we're working with scale, we want to set up a proportion. 45 feet goes on bottom. And how long will it be on the paper? That's the question, X inches. So 45 times 0.5 divided by 10. 2.25 inches. On paper, it'll be 2 1/4 inches long. All right, now I need to convert, or not convert, but I need to find the measurement on paper for 30 feet. So again, start with the scale, 0.5 inches over 10 feet.
This time you put 30.
And this time we'll put 30 on bottom. So X inches over 30 feet.
1.5.
and it will be 1.5 inches on paper. Okay, so you're gonna have to do a couple of these on your homework today where you have to set up two different proportions to find either the actual measurements or the paper measurements of a drawing like this. All right. The pillars of the World War II Memorial in Washington, D.C. are 17 feet tall. A scale model of the memorial has pillars that are 5 inches tall. Two questions: what is the scale of the model and what is the scale factor? So we don't know the scale or the scale factor at this point, but we do know that we have a model that's 5 inches tall, and we've got the actual measurement of 17 feet. What do I want for the scale? For the scale,
Equal sign.
an equal sign, and
Well,
what number do I want on top?
1 foot.
Not 1 foot. I'm not doing scale factor. I'm doing scale.
1 inch.
1 inch on top, and
Okay.
I don't know what the feet will be in real life. So x feet. So 1 times 17 divided by 5.
3.4.
Okay, so the scale is going to be 1 inch over 3.4 feet. That's kind of a weird measurement, but it can work. 1 inch equals 3.4 feet. Now that I have the scale, I want to convert this into the scale factor. So I can take 1 inch over 3.4 feet, and how do I change it to a scale factor?
1 foot on top.
Times 1 foot
And then 12 inches.
over 12 inches. Notice the difference. When we're working with scale, we leave the dimensions intact and use an equal sign. When we're using scale factor, we use multiplication sign, and we're getting rid of the dimensions.
1 over 40.8.
1 over 40.8. Okay, now I can measure in any unit I want, and I can make that conversion very simply. Okay? Recap here real quick. Scale, use proportions in the fish method. Scale factor, convert to the same unit of measure. So on this one, you're going to use an equal sign, and on this one, you're going to use 2 ratios, and you're going to multiply in between. Okay? Here's your homework.